So now we have got the software stacks and the code configurator tools to configure the microcontroller. Now all of this code is in the high level, which needs to be compiled into binary language format, that is of 0 and 1, and this is done by the compilers. Now in my computer system there are a couple of type of compilers. The compilers which are used in the microcontroller technology are the cross compilers. So we need embedded compiler tools, and there are number of compilers available for microcontrollers. One which is widely used is the GNU CCC, which is free and open source. Other compiler tools like DIPE compiler, GHS, IER are some industry specific compilers which are paid. Along with the compilers, there is use of software debugging tools. Like in hardware, we need hardware debugging tools to debug program of a microcontroller. Same way from software end, we need certain software files to do that. Like GDB and OpenOCD are software debugging tools which are required to connect the hardware debugger so that debugging can be done. And these are usually part of compiler package like GNU GCC. Also, there are other software tools to monitor and analyze the power consumption by the code which we have written for IoT applications, low power applications, RF analysis, and etc. To explore more in detail about different software tools for such requirements, one should explore the software development kit of a microcontroller. Apart from there is also a build automation tool as stated earlier, and build automation tool is used to automate the compilation process, linking process, all of these software files, compilation, debugging, all of this process automatically. And this is also the part of the compiler packages most of the time. And that wraps up this video in our microcontroller technology series. If you're ready to take your microcontroller skills to the next level, don't forget to save this playlist of what is microcontroller technology, as in this playlist over time you will find number of videos which will help you learn about these tips in chronological and interactive way by covering modern day industry level concepts, tools, and technologies, so as to become a skilled engineer and not just a graduated one. For viewers who wanted to expand their knowledge by hands-on practical learning, check out our Introduction to Microcontroller Technology course 101 built around the industrial grade NXP S32K144 microcontroller. This course dives deep into peripheral of modern day microcontrollers, teaching you real world tools and techniques and no more just theory. Head over to edu.gettobyte.com to learn more and get started. Let's keep learning, innovating, and building together, because a skilled engineer standouts, not just a graduated one. If you are new here, don't forget to subscribe for more in-depth tutorials and series videos. Hit the bell icon so you don't miss out our next videos, and explore the next video so as to continue your learning in a chronological way from here, and explore the full series playlist linked right here. Got any questions or ideas? Drop them in the comments below. We would love to hear from you.